Today's lesson is called Glacial Processes, Shaping the Land. In previous lessons, we have looked at cold environments and the Quaternary period. Today, we are going to focus on the actual processes glaciers use to shape landscapes. Glaciers may look slow and still, but they are incredibly powerful. Over thousands of years, moving ice can carve valleys, smooth rock, tear away huge pieces of bedrock, and leave behind clues showing the direction the ice once traveled. The big question for today is, how can ice shape some of the most dramatic landscapes on Earth? By the end of the lesson, you should be able to explain how glaciers break down, erode, and reshape mountain landscapes. Let's begin with the learning objectives. By the end of this lesson, you will be able to explain how freeze-thaw, weathering weakens mountain rock. You will also be able to describe the two main mechanical erosion processes used by glaciers, plucking and abrasion. You should be able to identify evidence of glacial movement through features called striations. Finally, you will analyze the role of meltwater in helping glaciers erode the land beneath them. The key thing today is understanding the difference between weathering and erosion. Weathering breaks rock down where it is. Erosion involves material being worn away and moved. Glaciers use both. Before we go further, let's go through the key vocabulary. The first word is weathering. Weathering means the breakdown of rocks in situ. That means the rock is broken down where it stands, without being moved away immediately. The second word is plucking. Plucking is a type of glacial erosion. It happens when meltwater freezes onto rock, and then the moving glacier pulls pieces of rock away. The third word is abrasion. Abrasion is sometimes described as the glacier acting like sandpaper. Rocks frozen into the base of the glacier scrape and grind against the bedrock underneath. The fourth word is striation. Striations are long, parallel scratches or grooves left on rock surfaces by stones dragged along underneath a glacier. These words are very important because they help us explain exactly how glaciers shape the land. A weak answer might say, the glacier breaks the rock. A stronger answer says, freeze-thaw weathering weakens the rock, then plucking removes blocks of bedrock, and abrasion smooths and scratches the valley floor. That is the level of detail we are aiming for. Before we can understand glacial erosion, we need to remember how glaciers form in the first place. We are currently living in the Quaternary period, which began around 2.6 million years ago. This period has been marked by repeated cycles of colder and warmer phases. The colder phases are called glacials. During glacials, temperatures were lower, snow and ice built up, and large areas of land were covered by ice sheets and glaciers. The warmer phases are called interglacials. We are living in an interglacial today. During colder periods, snow builds up year after year. If more snow falls in winter than melts in summer, it begins to compact. Over time, it turns into firn and then into glacial ice. Once the ice becomes thick and heavy enough, gravity causes it to move slowly downhill. That movement is crucial. Ice that does not move cannot erode in the same way. Glacial processes require thousands of years of cold conditions so that enough ice can build up and begin to flow. So let's do a question. Why does a glacier need to become very thick before it can shape the land? Here's the model answer. Because the weight of the ice creates pressure, allowing the glacier to move and erode the rock beneath it. Let's quickly check your understanding of the Quaternary period. Question 1. How long ago did the Quaternary period begin? Question 2. What is the name for the warmer periods between glaciations? Question 3. True or false? The British Isles were never covered in ice during the Quaternary. Write down your answers now. Try to answer without looking back. This is a quick retrieval task to strengthen your memory. Let's check the answers. Question 1. The Quaternary period began around 2.6 million years ago. Question 2. The warmer periods between glaciations are called interglacials. Question 3. The statement is false. Much of the UK was covered by ice during the Quaternary, with ice reaching as far south as areas near the Bristol Channel and the Thames. This matters because the landscapes we see in places like the Lake District, Snowdonia, and the Scottish Highlands were shaped by glacial processes during the Quaternary. Now let's think about the main puzzle of today's lesson. How can something like ice, which we might think of as soft or breakable, shape hard rock like granite? At first, it seems impossible. A block of ice in your freezer does not seem strong enough to shatter a mountain. But glaciers do not work alone. They use a combination of temperature changes, gravity, pressure, meltwater, and rocks trapped inside the ice. Think of a glacier as a giant moving toolkit. Freeze-thaw weathering weakens the rock. Plucking pulls rock away. Abrasion uses pieces of rock as tools to scrape and grind the landscape. Meltwater helps the glacier slide and can erode channels below the ice. So, the power of a glacier does not come from ice alone. It comes from ice, rock, water, pressure, and time working together. Let's start with freeze-thaw weathering. Freeze-thaw weathering is a type of mechanical weathering. Mechanical weathering means rocks are physically broken apart without changing their chemical structure. Freeze-thaw happens in places where temperatures regularly move above and below 0 degrees Celsius. There are three main stages. Stage 1 is infiltration. During warmer periods, water enters cracks in the rock. These cracks may already exist because of joints, weaknesses, or previous weathering. Stage 2 is expansion. At night, or during colder periods, the water freezes. When water freezes, it expands by about 9%. This expansion puts pressure on the rock around it. Stage 3 is fragmentation. This process repeats again and again. Water enters the crack, freezes, expands, and forces the crack wider. Eventually, pieces of rock break off. These broken pieces of rock often collect at the base of slopes as scree. Freeze-thaw is especially common in mountain environments because temperatures often fluctuate around freezing point. It is important to remember that freeze-thaw is weathering, not erosion. The rock is being broken down where it is. The glacier may later move the broken rock, but the freeze-thaw process itself is about weakening and breaking rock in place. Let's answer a question. Why would freeze-thaw weathering be less effective somewhere that is always far below freezing? Here's the model answer. Because the process needs repeated freezing and thawing. If temperatures stay below freezing all the time, water remains frozen and does not repeatedly enter cracks and refreeze. Now we move from weathering to erosion. The first major erosion process is plucking. Plucking happens at the base of a glacier. Even though glaciers exist in cold environments, pressure from the huge weight of the ice can cause some melting at the base. This produces meltwater beneath the glacier. That water seeps into cracks in the bedrock. When temperatures drop again, the water refreezes. As it freezes, it bonds the rock to the glacier. Then, as the glacier continues to move downhill, it pulls pieces of rock away from the bedrock. This is plucking. Imagine the glacier acting almost like sticky tape. It freezes onto loosened rock and then drags it away. Plucking is especially effective where the bedrock is already cracked or weakened, perhaps by freeze-thaw weathering. The slide reminds us that plucking often makes the down glacier side of rock outcrops look jagged and steep. That is because the glacier has ripped chunks of rock away as it moved over the surface. So, if we see a jagged, steep rock face in a glaciated landscape, plucking may be part of the explanation. Let's answer a question. What does plucking need in order to happen? Here's a model answer. It needs a moving glacier, meltwater, cracks in the bedrock, refreezing, and enough force to pull rock fragments away. Once rocks have been plucked and trapped inside the glacier, they become tools for another process, abrasion. Abrasion is when rocks frozen into the base or sides of the glacier are dragged across the bedrock. These rocks scrape, scratch, and grind the surface below. This is why abrasion is sometimes called the glacier's sandpapering effect. The glacier itself is powerful, but the pieces of rock inside it make it far more effective at erosion. Abrasion can smooth valley floors and rock surfaces. It can also grind rock into a very fine powder called rock flour. Rock flour can be carried away by meltwater, sometimes giving glacial rivers a cloudy or milky appearance. One of the clearest pieces of evidence for abrasion is striations. Striations are long scratches left on bedrock by rocks dragged underneath the glacier. They are very useful to geographers because they show the direction the glacier moved. That is why the slide calls them fossilized compass needles. Even after the glacier has gone, striations can still point in the direction of past ice movement. Let's ask a question. If you found striations running from north to south, what could that tell you? Here's a model answer. It could suggest that the glacier moved in a north-south direction across that rock surface. Now let's check your understanding with a process matchup. You need to match each term to the correct definition. The terms are 1. Weathering. 2. Scree. 3. Plucking. 4. Abrasion. The definitions are: A. Ice freezing to bedrock and pulling fragments away as it moves. B. Rocks stuck in the ice grinding against the bedrock below. C. Piles of jagged rock at the base of a slope caused by freeze-thaw. D. The breaking down of rock where it stands by physical or chemical means. Take 1 minute to match them. Make sure you are not mixing up plucking and abrasion. Plucking removes chunks of rock. Abrasion scrapes and grinds. Let's check the answers. Weathering matches with D. The breaking down of rock where it stands. Scree matches with C. Piles of jagged rock at the base of a slope caused by freeze-thaw. Plucking matches with A. Ice freezing to bedrock and pulling fragments away as it moves. Abrasion matches with B. Rocks stuck in the ice grinding against the bedrock below. A good way to remember the difference is this: plucking pulls, abrasion scrapes. That simple phrase can help you avoid mixing them up in an exam. Now let's look at the role of meltwater. Meltwater is water produced by melting ice or snow. It can travel through glaciers using cracks called crevasses and vertical shafts called moulins. Eventually, meltwater can reach the base of the glacier. Once it is there, it has two important effects. First, meltwater acts as a lubricant. It reduces friction between the glacier and the bedrock, helping the glacier slide more easily. This process is linked to basal slip, where the glacier moves over its bed. If the glacier can slide faster, it may also erode more effectively. Second, meltwater can erode the rock beneath the glacier. Because the ice above creates intense pressure, meltwater can move with great force. It can cut channels into the bedrock below. One surprising fact is that meltwater can sometimes flow uphill under a glacier. Normally, rivers flow downhill because of gravity. But under a glacier, pressure from the ice can force water through tunnels and channels in unusual directions. So, meltwater is not just a byproduct of melting. It is an important part of glacial movement and erosion. Let's ask a question. Why might more meltwater cause a glacier to move faster? Here's a model answer. Because meltwater reduces friction at the base of the glacier, allowing the ice to slide more easily over the bedrock. Let's now bring the lesson together. There are two major categories we need to separate: weathering and erosion. Weathering happens when rock is broken down in place. In this lesson, our key example of weathering is freeze-thaw weathering. Water enters cracks, freezes, expands, and eventually breaks the rock apart. Erosion happens when material is worn away and moved. The two key glacial erosion processes are plucking and abrasion. Plucking happens when meltwater freezes onto bedrock and the moving glacier pulls rock fragments away. Abrasion happens when rocks embedded in the glacier scrape and grind against the bedrock. Water is involved in several ways. Freezing water helps drive freeze-thaw weathering and plucking. Liquid meltwater lubricates the base of the glacier, helping it move through basal slip. Together, these processes can transform a narrow V-shaped river valley into a much wider, deeper U-shaped glacial trough. So, the glacier does not shape the land through one process alone. It is the combination of weathering, plucking, abrasion, meltwater, gravity, and time that creates dramatic glacial landscapes. Now we are going to apply your knowledge. Imagine you are a geographer standing on a mountain in the Lake District. You see jagged, pointed peaks high up. Below, the valley floor is smooth, and there are long scratches on the rocks. Based on what you have learned today, how would you explain how these different features were formed by the same glacier? This is asking you to connect evidence with processes. Jagged peaks suggest freeze-thaw weathering. High up, above or near the ice line, water repeatedly froze and thawed in cracks, breaking rock apart and creating sharp, angular features. The smooth valley floor suggests abrasion. Rocks frozen into the glacier scraped across the bedrock, smoothing and polishing it. The long scratches are striations. These were caused by rocks dragged along the bed by the moving ice. They show the direction of glacier movement. Plucking may also have removed larger blocks of rock, creating steeper and rougher surfaces in places. Take a moment to write your answer in a paragraph. Here's a suggested sentence starter. The jagged peaks were formed by, whereas the smooth valley floor was formed by. Here is a model answer. The jagged peaks were formed by freeze-thaw, weathering above the ice line. Water entered cracks in the rock, froze, expanded, and eventually broke pieces away. The smooth valley floor was formed by abrasion, where rocks embedded in the glacier scraped and ground against the bedrock. Plucking also removed larger blocks of rock as meltwater froze into cracks, and the moving glacier pulled rock away. The long scratches, called striations, show the direction the glacier moved. This is a strong answer because it uses key vocabulary and links each landscape feature to a specific process. It does not simply say the glacier made it. It explains how. Next lesson, we will move from processes to landforms. Today, we learn the tools glaciers use: freeze-thaw weathering, plucking, abrasion, and meltwater erosion. Next, we will look at what those tools create. We will study features such as corries, arêtes, and pyramidal peaks. These are some of the most dramatic landforms in glaciated landscapes, and you will be able to explain how they form using the processes from today's lesson.